Imagine you're defending a castle. You need to know where attackers can get in, right? The main gate, side doors, windows, walls that might be climbed, maybe a secret tunnel someone forgot about. Every one of those entry points is something you need to protect. Miss one, and that's how the enemy gets inside. In cybersecurity, we have the exact same problem, but instead of a castle, it's your entire digital infrastructure. And instead of gates and walls, it's APIs, web applications, user accounts, network ports, and thousands of other potential entry points. This is called your attack surface, and understanding it is absolutely fundamental to security. Whether you're just starting in cybersecurity, you're an IT professional, or you're just curious about how security actually works, this video will give you a complete understanding of one of the most important concepts in the field. Let's break it down. So what exactly is an attack surface? In the simplest terms, your attack surface is the sum total of all the points where an unauthorized user could try to enter your system, extract data, or cause damage. It's every door, window, and potential entry point into your digital environment. Think of it as the boundary between your organization and the outside world. But it's not a simple wall, it's a complex, multi-dimensional perimeter with thousands of potential access points. Every service you expose to the internet, every device connected to your network, every piece of software you run, every employee who has access to systems, they all contribute to your attack surface. Here's why this matters. The larger your attack surface, the more opportunities attackers have to find a weakness and exploit it. It's basic math. If you have 100 potential entry points versus 10, attackers have 90 more chances to find that one vulnerability you missed. Security professionals spend enormous amounts of time trying to understand, map, and ultimately reduce their attack surface, because you can't defend what you don't know exists. That forgotten test server, still connected to the internet? That's part of your attack surface. That API endpoint nobody documented, part of your attack surface. That employee working from the coffee shop on public Wi-Fi. Yup, part of your attack surface. Attack surfaces come in different categories, and understanding these helps you think comprehensively about security. The digital attack surface is what most people think of first. This includes everything connected to networks, web applications, mobile apps, APIs, servers, databases, network infrastructure, cloud services, IoT devices. Basically, anything that processes data or communicates digitally is part of this surface. Web applications are a huge component. Every form that accepts user input, every authentication page, every API endpoint is a potential entry point. If it's accessible over the network, it's part of your attack surface. Then you have the physical attack surface. This includes physical access to devices, servers, network equipment, and facilities. Can someone walk into your office and plug a USB drive into an unlocked computer? That's physical attack surface. Are your server rooms secured? Are decommissioned hard drives properly destroyed? Physical security is still security. The social engineering attack surface involves your people. Every employee is a potential target for phishing, pretexting, or manipulation. Their knowledge of systems, their access to credentials, their trust in communications, all of this can be exploited. The human element is often the largest and most vulnerable part of your attack surface. And increasingly, we need to think about the supply chain attack surface. This includes third-party vendors, software dependencies, cloud service providers, contractors, anyone who has access to your systems or whose security failures could impact you. You might have perfect security, but if your vendor gets compromised and attackers pivot through them to reach you, your attack surface included that relationship. Let's clear up some terminology because these concepts get confused. Attack surface versus attack vector. Your attack surface is all the possible entry points, the landscape of opportunities available to an attacker. It's the what and where. What systems are exposed? Where can they be accessed from? An attack vector is the specific path or method an attacker actually uses to exploit one point on your attack surface. It's the how. How did they get in? What technique did they use? What vulnerability did they exploit? Here's an analogy. Imagine a building with 10 doors and 20 windows. Those 30 entry points are the attack surface. When a burglar picks the lock on the back door specifically, that's the attack vector. the actual method used to exploit one point on the surface. In cybersecurity terms, your web application is part of your attack surface. SQL injection is an attack vector that exploits that surface. Your email system is part of your attack surface. Phishing is an attack vector that exploits that surface. Understanding this distinction is crucial, because attack surface management is about reducing opportunities, while defending against attack vectors is about blocking specific techniques. You need both, but they're different security activities. Let's get more specific about what actually makes up your attack surface in a modern organization. Network-exposed services are the most obvious. Any port you have open to the internet, any service listening for connections, web servers, email servers, FTP servers, VPNs, remote desktop services. Each one is an entry point that needs to be secured. Applications are massive contributors. Web applications, mobile apps, desktop software. Each one processes user input, communicates over networks, stores data. Every feature, every input field, every API call is a potential point of exploitation. Modern applications are complex, and complexity breeds vulnerabilities. User accounts and authentication systems are critical attack surface components. Every username and password combination is a potential target for credential stuffing, brute force, or phishing attacks. Privileged accounts, administrators, root users, service accounts are especially valuable targets. Devices expand your attack surface significantly. Every laptop, phone, tablet, IoT device, server, network switch, and router is a potential entry point. Bring your own device policies dramatically increase attack surface because you're now responsible for security on devices you don't fully control. Code and software dependencies are part of your attack surface too. Every library, framework, and third-party component you use could contain vulnerabilities. That popular JavaScript library everyone uses. If it has a security flaw, every application that includes it inherits that vulnerability. Data storage and transmission points matter too. Databases, file servers, backup systems, cloud storage. Wherever data lives, that's part of your attack surface. So are the channels through which data moves, network connections, API calls, data exports. And don't forget about your people. Every employee, contractor, and partner who has access to systems, knowledge of infrastructure, or ability to approve actions contributes to your social engineering attack surface. Here's something every organization struggles with. Attack surfaces naturally grow over time, and they grow faster than most people realize. Digital transformation is a major driver. Moving to the cloud. You just expanded your attack surface to include cloud infrastructure, cloud service APIs, and identity and access management systems. Developing a mobile app, new attack surface. Adding IoT devices, more attack surface. Every new technology adoption increases the number of potential entry points. Business growth contributes too. New employees mean more user accounts, more devices, more potential for human error. Opening new offices means more network perimeter, more physical locations to secure. Acquiring another company, you just inherited their entire attack surface, including whatever security problems they had. Shadow IT is a silent killer. These are technologies and services that employees or departments deploy without IT's knowledge or approval. Someone spins up a cloud database to make their job easier, creates a file-sharing service, or uses an unapproved communication tool. IT doesn't know it exists, so it's not secured, monitored, or managed. But it's absolutely part of your attack surface. Legacy systems that nobody wants to touch but everyone depends on. Those expand your attack surface with outdated, unpatched software that's often running on unsupported operating systems. They can't be easily updated without breaking something, so they just sit there, vulnerable and exposed. And here's the subtle one: accumulated technical debt. Quick fixes that were supposed to be temporary become permanent. Test environments that were meant to be isolated end up connected to production. Documentation falls behind reality. Over time, nobody has a complete picture of the infrastructure. which means nobody has a complete picture of the attack surface. Managing your attack surface is an ongoing process, not a one-time project. So how do organizations approach this? First, you need visibility. You can't manage what you don't know about. Asset discovery tools scan your network to find devices, services, and applications. External attack surface management platforms scan from the attacker's perspective, identifying what's visible from the outside. You're building an inventory of everything that could potentially be targeted. Attack surface mapping goes deeper, documenting not just what exists, but how things connect, what data flows where, what dependencies exist. This gives you a topology of risk. Once you know your attack surface, the next step is reduction. This is the principle of minimizing your exposure. Shut down services you don't need. Close ports that aren't necessary. Decommission systems that are no longer used. Every component you eliminate is one fewer thing to protect. Segmentation is powerful. You can't always make your attack surface smaller, but you can compartmentalize it. Network segmentation, micro-segmentation, zero-trust architecture. These approaches limit how far an attacker can move if they compromise one point on your surface. Hardening is about making each component of your attack surface more difficult to exploit. Patch management, configuration standards, removing default credentials, disabling unnecessary features. You're reinforcing each entry point so that even if it's part of your attack surface, it's not an easy target. Continuous monitoring means watching your attack surface for changes. New services appearing, configuration drift, unauthorized access attempts. Attackers are constantly probing, so you need to constantly watch. And then there's prioritization. Not all attack surface is equally important. Internet-facing systems that handle sensitive data are higher priority than internal test systems. Crown jewel assets need more protection than less critical infrastructure. Let's make this concrete with some real-world scenarios. Consider a typical e-commerce company. Their attack surface includes the public-facing website, mobile shopping app, payment processing API, customer database, employee email, admin portal, cloud infrastructure, third-party shipping integration, marketing analytics platform, customer service chat system, and every laptop their employees use. Each of these has its own vulnerabilities and potential attack vectors. Now imagine they want to reduce their attack surface. They could implement two-factor authentication to make user accounts harder to compromise. They could move their admin portal behind a VPN so it's not internet accessible. They could consolidate 3 different payment processing systems into one well-secured solution. They could implement application firewalls to filter malicious traffic to their web apps. Each action reduces the opportunity for attackers. Or consider a healthcare organization. Their attack surface includes medical devices, electronic health record systems, patient portals, insurance claim processing, facility access controls, and potentially life-critical systems. The attack surface is enormous, and the consequences of compromise are severe. They need to prioritize. Securing systems that could impact patient safety comes before securing the cafeteria's point-of-sale system. Your attack surface is the foundation of your security posture. It's every door an attacker might try to open, every window they might try to climb through, every weakness they might try to exploit. Understanding your attack surface is the first step toward securing it. You can't defend what you don't know exists, and you can't prioritize protection if you don't understand your exposure. And remember, in security, visibility is the beginning of control. Stay secure out there.